Welcome to Brain Vision.
Our question states that 1 liter, or 1,000 cubic centimeters, of oil is spilled onto a smooth lake. If the oil spreads out uniformly until it makes an oil slick just 1 molecule thick, with adjacent molecules touching, estimate the diameter of that oil slick. Assume the oil molecules have a diameter of 2 times 10 to the minus 10 meters. Okay, so I wrote down here what we have given in the question. It tells us the thickness of the oil, which is the diameter of the molecules, and I wrote that thickness as T, which is equal to 2 times 10 to the minus 10 meters. The volume of the oil in question is 1,000 cubic centimeters, which I convert to cubic meters by multiplying it by the conversion between meters and centimeters, where 1 meter is equal to 100 centimeters. You cube that because we're dealing with volume, and we want cubic meters from cubic centimeters. This gives us 0.001 cubic meters. The question then is, how big is the diameter of this oil slick if we're assuming it's spreading out in a spherical or circular manner? Well, the volume of the oil is equal to the area of the oil multiplied by the thickness of the oil. Okay, well, the area is equal to pi r squared, right? And then that's going to be multiplied by the thickness of the oil, because pi r squared is the area of a circle. Well, r is equal to diameter, so the radius is equal to half the diameter, right? So we know what r is equal to. It's equal to, so like pi, r is equal to d divided by 2, the diameter divided by 2, squared, times the thickness. So now we have our equation for volume is equal to pi times the diameter divided by 2 squared times the thickness. Well, we know the volume and we know the thickness. So, and pi is just a constant. So we need to solve for the diameter, and we will be able to calculate our question, or the solution to our question. So the diameter squared, we'll just leave it as squared for now. Excuse me. The diameter squared is equal to the volume, right? So you have the volume on one side of the equation. You need to divide that by the thickness. So it's equal to the volume divided by the thickness. You also need to divide the volume by pi. So 1 over pi. And then the 2 squared is on the bottom on the right-hand side of the equation. So when you're putting it in terms of d, you need to multiply the volume by 2 squared just being 4. Okay, so now we can again rewrite this in terms of d by taking the square root of each side. So d is equal to the square root of 4 times the volume divided by the thickness times pi. Okay? So if you plug in everything that you would need for this equation, which we already have, the volume is 0.001 cubic meters and the thickness is 2 times 10 to the minus 10, you get 2,523 approximately. And there's a couple of decimal places there, right? This is approximately. But in the question, we're given the thickness as 2 times 10 to the minus 10. This has one significant figure. So our maximum accuracy we can report to is one significant figure. So we can round this to 3,000, or, and this is meters, excuse me, I forgot dimensions. 3,000, or 3 times 10 to the third meters. Go ahead and box that in.